Hey boys and girls, sorry that I am out today, but I needed to take care of some family business, so I'll be back on Monday. Okay, today we are talking about graphing functions using a table. So yesterday we already talked about domain and range and how to tell whether something's a function given a table, a graph, and an equation. So today we're going to learn how to take the equations and see what kind of functions or pictures they actually make. So to graph an equation, you must make a table of values that has at least 5 ordered pairs. So this is my function rule. So what I do is I make a table. One column is x, one column is my rule, one column is y. Remember, x is your inputs, y is your outputs. So you drop the x into the machine, it applies this rule, spits out a y. Well, guess what? Today you are the machine. You're going to do the number crunching. So if I will have to use 5 values, I always like to use some that are negative and some that are positive because it gives us a really nice picture of what we're looking at. So then I substitute in 3 times negative 2 minus 5. Well, 3 times negative 2 is negative 6. Negative 6 minus 5 is negative 11. Plug in negative 1. Negative 1 times 3 is negative 3, minus 5 is negative 8. Plug in 0. Plug in 1. Plug in 2. Okay, then I graph. Negative 2, 11. Well, that is off my graph. Negative 1, negative 8. That is also off my graph. Sorry. Negative 2, negative 11 would be down here. Negative 1, negative 8 is also off my graph. So 0, negative 5. That's the first point I can graph. Then 1, negative 2. And then 2, 1. Okay. Then I connect those points. I make a nice line using a ruler. I put arrows on it, and I label this line with its function rule or function name or the equation. Okay, so choose 5x values, substitute them in, fill in the y values, plot the ordered pairs, connect using a straight edge, extending beyond the first and last point, and then we label with the equation. Okay, let's try another one. This time I've got negative 2x plus 4. So I put that in. I use my values that I like to use. I'm going to substitute. Some kids like to write all the substitution, which I guess you could do. And then they like to go back and do the math. So negative 2 times negative 2 is 4. 4 plus 4 is 8. Negative 2 times negative 1 is 2. 2 plus 4 is 6. 0 plus 4 is 4. Negative 2 plus 4 is 2. Negative 4 plus 4 is 0. So then I plot negative 2, 8. Negative 2 on the x. 8 on the y. Oh, off my graph. Negative 1, 6. Negative 1, 6. 0, 4. So I'm using my graphing skills from my last couple units and from 7th grade. 1, 2. 2, 0. Ruler. Connect. Label. Okay, so my first one was a line slanted to the right. My second one was a line slanted to the left. Let's see what's next. Okay, so I'm going to put my function in here. Okay, I'm going to be a little bit careful about the way I choose my values. I know I'm multiplying by a half, and I know I can't graph fractions over here, so multiplying by a half is the same as dividing by 2. So I'm not going to choose numbers for inputs that are not divisible by 2. So if I chose 3 as an input, I'm going to get a fraction, I can't graph it. If I chose 1, I'm going to get a fraction, I can't graph it. So I'm only going to choose values here that are actually divisible by 2. So 1/2 of -4 plus 1. Well, half of -4 is -2, plus 1 is -1. Half of -2 is -1. -1 plus 1 is 0. Half of 0 is 0, plus 1 is 1. Half of 2 is 1, plus 1 is 2. Half of 4 is 2, plus 1 is 3. So now I can plot these. -4, -1, -2, 0, 0, 1, 2, 2, 4, 3. So again, I have a line that slants to the right. Not as steep as the first one that slanted to the right, but it still slants to the right. I give it a label. Okay, ooh, a little trickier. I've got an x squared. The only thing being squared is the x, not the 2 in front. So they gave me my values. So 2 times -2 squared minus 4. Well, -2 squared is 4. 4 times 2 is 8. 8 minus 4 is 4. Okay, some of you at this point might need to use your calculators, especially if you're not good with the negatives. Just make sure that you include the parentheses when you put it in your calculator, otherwise you will get it wrong. So -1 squared, -1 times -1 is 1. 1 times 2 is 2. 2 minus 4 is -2. 0 squared is 0. 0 times 2 is 0. 0 minus 4 is -4. 1 squared is 1. 1 times 2 is 2. 2 minus 4 is -2. 2 squared is 4. 4 times 2 is 8. 8 minus 4 is 4. Look at that. 4, 4. Let's graph it. -2, 4. -1, -2. 0, -4. 1, -2. 2, 4. Oh, this is that U shape we saw in class yesterday. It is a U, which means it has a curvy bottom. Do not make the bottom pointy. That is a different mathematical graph. It needs to have a curved bottom. And then I write the label. Okay. So this was the first problem we had where we had an x squared. Okay, and it was the first one that was also the shape of a U. I wonder if that's going to mean something. Let's try this one. It's also an x squared. What do you think it might look like? So positive 4 plus 3 is 7. 1 plus 3 is 4. 0 plus 3 is 3. 1 plus 3 is 4. 4 plus 3 is 7. Has that same pattern, kind of goes down and comes back up. So I'd imagine my graph would go down and come back up. And it does. My graph goes down and comes back up with a curvy U shape. It gets a label. Okay. So, using the last 5 graphs you made, how can you tell by looking at the equation of the function, or the rule of the function, whether it will form a line or be linear. See how linear has the word line in it? It's not linear, it's linear. Or be curved, which we call a quadratic. Explain. So let's look. Straight line, look at the equation. Line, look at the equation. Line, look at the equation. Look at the equation. So this is tricky. The picture is called a parabola. Not a parabola, but a parabola. And the equation is called a quadratic. Okay? So the equation is a quadratic, the picture is a parabola. So same thing here. Picture is a parabola. The equation is a quadratic. Okay, so hopefully you notice when x is to the first power, it's a line. When x is squared, it's a quadratic. So, and x, or x to the first, makes a line. And x squared makes a parabola. Parabola. Sorry, I couldn't spell it for a second. Okay. So state whether the point whose coordinates are given is on the graph of the line. So if this is on the line, that means it works in this equation, which means if I dropped a 4 into the machine, it would spit out a 3. So this is in x's position, this is in y's position. It's an ordered pair. So the 4 goes in for the x, the 3 goes in for the y. So I'm checking to see, is 4 plus 3 7? Yes, it is. So this answer is yes. Okay, over here, 1 goes in for x, 3 goes in for y. So 6 plus 1 equals 7, 7 equals 7. So that, again, is a yes. If I got a false statement, like 4 equals 5, then I would answer no. Okay, so here I'm looking for k, which is really x. So k plus 2 times 2 equals 5. Now it's algebra. Okay, same thing over here. K is now y. So k equals -1. And lastly, what is the value of the x coordinate when the y coordinate is -41? So I take this equation. They're telling me y is -41. I put it in for y. I want to find x, so I solve it for x. X equals 17. And that's it, guys. You are going to practice your skills on pages 9 and 10, and I will see you guys all again on Monday. Have a good weekend.